Alright, so we are going to talk about the classification of matter today. The notes that you're going to be using are page 8 in your packet. Remember, you can annotate them digitally, you can print them off, you can just write them in your notebook, which is probably what I would do. So we've talked about what matter is, and again, it's anything that contains atoms. And then matter can be broken down or can be separated into two different groups. We have pure substances and we have mixtures. Pure substances, we have a choice of either elements or compounds, and then mixtures can either be homogeneous or heterogeneous. So the first thing we're going to talk about is a mixture. A mixture is two or more pure substances that can be separated by a physical change. Again, remember, a physical change can be simple things like evaporation or phase changes. The first one we'll look at is a homogeneous mixture. These are two or more pure substances that are mixed evenly. So when you look at it, you cannot tell this, see the separate parts. So homo meaning the same. We are all homogeneous. So examples would be solutions are an excellent example of a homogeneous mixture. So salt water we talked about previously, sugar water again, soda, not with the bubbles necessarily, but the sugar, the color, the flavoring, all of that. Coffee, my favorite homogeneous mixture, and you could think of many others. It's really easy to think of food examples, and we will specifically look at chemistry examples in a little bit. The next one is a heterogeneous mixture. This is when two or more pure substances are mixed unevenly. Hetero meaning different. So example again, food examples would be fruit salad. If you only like the grapes, you take out the grapes. Pizza. In my family, if the girls don't want mushrooms, they pick off the mushrooms. Sandwiches. Oh, you didn't want a tomato, you can take off the tomato. So we can see the differences. And it's not mixed evenly. Then we're going to go over to the pure substances side and first look at elements. So elements we can find on the periodic table, 118 now, that cannot be separated by chemical change or a physical change. They are represented by a symbol on the periodic table. Remember, you are learning your elements, and be very careful about the symbols. If it is just one letter, it is always capitalized. If there are two letters, the first letter is always capitalized, the second is always lowercase. So hydrogen would be a capital H. Helium, capital H, lowercase e. Gold, capital A, lowercase u. Mercury, capital H, lowercase g. Lead, capital P, lowercase b. And chlorine, capital C, lowercase l. And we could go on and on. So this is interesting. A good little vocabulary word is called an allotrope. It is the same element but with different bonding. Carbon does this. So carbon can bond in different ways. One way that it bonds very strongly in a crystalline lattice would be a diamond. Very, very hard. And we know the physical characteristics of a diamond. But it's also graphite. You know, the not lead, the graphite that would be in your pencil. That way that it is bonded is in sheets, and when you write, those sheets of graphite come off on your paper, leaving your writing. So they're only made up of carbon, just bonded differently, and those are what they're called allotropes. Now we're going still pure substances, and we're on compounds. These are made up of atoms that are chemically bonded, generally two or more atoms that are chemically bonded together. They can be separated by chemical change, but not physical means. So one of the ways that I remember that is we have the alliteration. So we've got compounds are chemically bonded. It can be separated by chemical change. So you have the CCC. They are represented by a formula. So for instance, H2O, we have two hydrogens and one oxygen, water. CO2, one carbon, two oxygen, carbon dioxide, and NaCl, sodium chloride, one sodium, one chloride. So that is a compound. So if we look at the microscopic practice, some of these repeat, but we'll look at it. So the one on the left, it's just those blue spheres. This would be, you ask yourself, is it a pure substance or a mixture? In this case, it's a pure substance, and it is just one of those spheres, or it's representing an atom, so that would be an element. If we look at the one in the middle, again, pure substance or mixture, this is a pure substance, and they are chemically combined, so these are compounds. The one on the right, did I say left? I don't know. Okay, I'm pointing with it. The one on the right is going to be also pure substance, and they are elements. All right, the one on the left is, we've got two different types of compounds here. They seem pretty evenly mixed, so we're talking about a mixture, not a pure substance, and because they're evenly mixed, it is homogeneous or homogeneous. Again, the middle one, again, it's repeated from the previous one, that is a pure substance and is a compound. The one on the right, it's a mixture, but notice how it's not evenly dispersed or evenly spaced, so this would be heterogeneous. We can see the difference. Okay, the one on the left, pure substance, not a mixture, and those are compounds. The one in the middle, even though those are the same atoms, they are chemically combined. We will learn about 7 elements that like to be in pairs. So this would be a compound. And then if we look on the right, this is one that we saw in the previous slide. It is a mixture, and it's evenly distributed, so that would be a homogeneous or homogeneous. Again, the one on the left, pure substance element. The one on the right, pure substance compound. All right, so now what we're going to talk about are the chemistry laws. The first one we'll talk about is the law of definite proportions, or sometimes called the law of constant composition. What it says is that water, or any compound, will always contain the same elements in the same proportion. Doesn't matter where it's from or where you get it. If it is water, it will always have 2 hydrogens and 1 oxygen. If it is carbon dioxide, it will always have 1 carbon and 2 oxygens. Hydrogen peroxide, H2O2, it will always be 2 hydrogen, 2 oxygen. They will always be in that very specific ratio for that compound. Then we have the law of multiple proportions. It says that when elements combine to form compounds, they combine in whole number ratios. So you have CO, which is carbon monoxide, and you have carbon dioxide, CO2, but you would never have like CO 1.5 or C2.50. You never would have that. They have to be in whole number ratios, but it shows it by the mass. And then we've got our law of conservations. So the one that I know that you've probably heard before is the law of conservation of mass, that matter can't be destroyed or created. It can change, it can be transformed. And what I like to say is that chemistry is not magic. We're not magically producing something, we're not magically making something disappear. We need to account for where it came from and where it's going to. And later on in this year, we will talk about that and show that in a chemical equation. We also have the law of conservation of energy, saying that energy cannot be created or destroyed. Again, energy is not magic either. It has to come from somewhere, and it's got to go somewhere, or it's got to be transformed into something. So, for instance, we talk about a car. The gasoline would be chemical energy. That is transformed into mechanical energy to move the parts. To make it go would be kinetic energy. The car gets hot because it's an internal combustion engine, so it's thermal energy. It's not silent, it is sound energy. It can produce electrical energy. It converts into so many different types of energy. So that is one of the things that we will talk about as far as chemistry and compounds and bonds this year. All right, so now on your periodic table, you can find one, or if it's in your packet, you're going to draw the zigzag line. Yours doesn't have it. So the zigzag line is here. So it's going to be below boron, and then between aluminum and silicon, below silicon between germanium and arsenic, below arsenic between antimony and tellurium, below tellurium between polonium and astatine. And I just brought it down. Even those are brand new. I'm not really sure that it even extends that way, but it's a trend and we'll just go with it. Okay, so that is the metalloid line, that zigzag line. And then what I want you to do is I want you to choose your favorite metal. Mine is platinum, PT. So I've got platinum boxed. So when I have a brain fart, something happens, and I'm like, I don't remember what side metals are on. I am going to remember where my favorite metal is and know that all the metals are to the left of that metalloid line. The elements that are to the right of the metalloid line are called nonmetals. And then if they are actually on the line, flat on the line, one way or the other, those are metalloids. So they have characteristics of both metals and nonmetals. If it is a vertical column like this, these are called groups. If it is a horizontal line, it's called a period. Groups are also called families. They have similar characteristics. Periods are just periods. They have no characteristics similar to each other at all. And then the last slides on this PowerPoint, slide number 48 to 53, those are a really good little review, little practice quiz for you to do. So you will do that. The other things that you will do are you're going to watch, complete the Seneca learning modules today. And then you will also watch videos 1 and video 2 that are on our calendar. You scroll up here, here they are right here. So you're just going to click on the hot links for those 2 videos. And then you are free to work on this yourself. I will talk to you soon. Have a great day. Bye.